Okay, so I want to continue with Unit 3, Lesson 4 with the last two examples that are in the notes. There was another definition of derivatives involving limits, and that was, or is rather, the limit of a function, f of x, minus the function evaluated at a, all over x minus a. And instead of h approaching 0 in this definition, we have x approaching a. So let's look at this for a second. Notice that if x is approaching a, and if we substituted a here, we'd have a minus a, which is 0. And if we plug a in for this x, this would be f of a minus f of a, which would be 0, and 0 over 0, what we talked about before, would be to do more work. But with this being the definition, an alternative definition for the derivative, I wanted us to take a look at a couple of examples to be on the lookout for. So if you look at the first example with that, we have, I want us to find the limit of x squared minus 4 over x minus 2 as x approaches 2. Now, just for the sake of reminding us, anytime you find a limit, your goal is to substitute, or your first approach is to substitute 2 for x into the expression. And if we did, we would have 2 squared minus 4 over 2 minus 2, which does give us 0 over 0. So, because that turns out to be the indeterminate form, we need to approach this from a different perspective. I can either do more work on the expression, or if I look closely, what I have here is really f of x minus f of 2. Notice that this is 2, so x is approaching 2, so that's my a value. So my function f of x equals x squared, and 4 is the result of substituting 2 into f. So our a value is 2. So if we wanted to find the derivative of this function and then substitute 2, then we would have the limit of this function, and they should be the same thing. So let's find the derivative. The derivative of x squared is 2x. If I substitute 2 for x, I get 2 times 2. That equals 4. So since the derivative evaluated at 2 is 4, then the limit of this function as x approaches 2 is also 4. So if we wanted to look at this, let's say we didn't notice this as the derivative perspective. Let's look at this from a limits perspective. Since substituting 2 here and here produces 0 over 0, then we could take this example, the limit as x approaches 2, doing more work on x squared minus 4. This is a difference of squares, so it could be factored into x plus 2 times x minus 2 over x minus 2. Let me scoot that over. If I cancel, notice that I have a binomial that will cancel. And now I can substitute 2 in for the 2. And what's 2 plus 2? It is 4, which is the same thing. Okay, so sorry about that. There's my 4. And there's the derivative evaluated at 2, which gave us 4 also. So there's 2 approaches, but this definition of a derivative is useful, especially when the do more work is not obvious. All right, so let's do one more. So I have a limit. I want us to find the limit of 4x to the 5th minus 4 over x minus 1 as x approaches 1. And I notice in the denominator I have x minus 1 and I have x approaching 1. And if I substitute 1 for this x and also this x, I'm going to get 0 over 0. So I either have to do more work, or if I look closely, I can look at this as a function f of x minus f of, well, how do I know what this has got to be the result of? Well, that right there. This would be f of 1. Let me rephrase that. How would I know what 4 has to be the result of? Well, 4 has to be the result of evaluating f at a number. And how do I know what number that would be? It would be this number right here. Okay, so now the question is, what's the function? Well, our function is going to be this piece right here. So it's f of x equals 4x to the 5th. If I find the derivative of x, that would give me 20x to the 4th. And now I want to evaluate the derivative at 1. So 20 times 1 to the 4th equals 20. So f prime of 1 equals 20. Therefore, the limit as x approaches 1 of 4x to the 5th minus 4 all over x minus 1 is also 20. Okay? So, there you go. So, here are two different expressions for derivatives of functions using the definition of a limit, or definition of derivatives, which includes limits. And so it's just another tool that you can use to evaluate limits that can be a little complicated or a little challenging to use traditional algebraic methods. So that's what lesson 4 was all about. Lesson 5 is going to again be using and working with limits. And we're going to have yet another tool that we can use to find limits using derivatives. So that's all for this lesson. As always, if you need anything, just let me know.